Live long and prosper. So continue, more examples. And this example is about determining the coordinate of the centers also of areas. And all these problems are solved basically in the same way. Remember our equations is x bar equal the summation from I equal 1 to n of xi ai divided by the summation from I equal 1 to n of ai. And the same situation applies for y bar. We are in 2D. So summation from I equal 1 to n of yi ai divided by the total area, which is the summation of the individual areas, weighted average of the centroids, in other words. How do we do this? We do this in the same way that we always do these type of problems. First, set up our axes. In this case, the axes are set up for us. But if we have to set up the axes, I always recommend you to place those axes in such a way that the figure is in the first quadrant, which it is in the first quadrant, so I don't measure negative distances, and at the same time, as close as possible to the figure. Why I don't like negative distances? Because in some cases I have negative areas, and then you are going to start wondering, oh, does a negative distance times a negative area gives me a positive value? I don't want that happening. So I want to minimize the chance for errors. Once you have that, then you have to recognize and divide these in figures in such a way that it's easier for you to do it. Usually the minimum amount of figures is what you're looking for. Well, here it's pretty obvious that I can use this figure and I can say, okay, let's solve this problem. This problem is going to be, first of all, is going to be this figure, which is the base. This is 30 and this is 90. Plus, I'm going to use this other part as a solid figure, this one. My figure 2 is going to be somewhere here, like that, solid. It's hanging 30 millimeters from the axis here, and this height is 50, and of course this is 40. Why 40? Because this is 20 plus 20, 40. And then I'm going to add this part on the top, which is 30, 30, 80. This is 80, hanging in the air, 80, and this is 40 in this part. And then I have to subtract 3 parts. I have to subtract first this, and then this, and then this. So then I'm going to subtract, first of all, I'm going to subtract this, I'm going to subtract this, and I'm going to subtract this. That's what I have to do. And this is the way we are going to be solving this problem. So let's start from the beginning, and let's start here with figure AI, XI, and then we have YI, and AI, XI, and AI, YI. Okay, remember the units. We have to put the units here. This is everything in millimeters, so this is going to be millimeters square. This is going to be millimeters, millimeters, millimeters to the third, and millimeters to the third. Those are the units. And let's start with our first figure. The first figure, which is this one, the area is 30 times 90, 2700. XI, well, the center is located at the center, right? So XI is going to be 45 and YI is going to be 15. And then you do the multiplication. This times this is 121,500, and this times this is 40,500. Next figure is this one, and I say my next figure was going to be this, hanging in the air 30, and the center is going to be located right there. First of all, the area is 40 times 50, that's 2000. coordinate in x is going to be at the center, which is 20. And the coordinate in y is going to be at the center of this part. This is 25 because this is 50. And then it's going to be 25 plus 30 because remember I have to measure it from this axis. So 25 plus 30 is 55. Multiply this times this, 40,000. Multiply this times this, 110,000. There you go. Third, this shape. Let's go with that shape. That shape is this one. What is the area? Pi r squared divided by 2. Because it's a semicircular area. Centroid right there. How much is pi r squared divided by 2? 628.32, which is basically r is, how much is r here? R is 40. So 40 squared divided by 2. 40 is r squared divided by 2. This is not 40, this is 20. I mean the r is 20. So 20 squared is 400 divided by 2 is 200 pi. If you want to just do it like that, because the r is 20. X is going to be right there at the center because it's symmetric at the center, and that center is 20. But now y, remember you have this shape, and if you look at the book again, or the books or any back of static books usually come with these tables. Areas, lines, don't get confused, we're working with areas. And from this line, from the x axis here, the centroid is located at 4r divided by 3 pi. So this is going to be my centroid, 4r divided by 3 pi. This distance is going to be 4r divided by 3 pi. But remember, we are not from here. We have to measure it from the base. So it's going to be the total distance from here to here, or from here to here, 80, plus 4r divided by 3 pi, and r is 20. So you want to put it by pieces here, you can put it by pieces. If you want to calculate it, you calculate it. So the total distance is going to be 80 plus 4 times 20 divided by 3 pi. That is 88.49. Do it if you want to. I mean 80 plus 4r, 4 times 20, divided by 3 pi. And that should give you that value. Now multiply this times this, and that value is 4,000 pi, or is 12,566.37. And this times this is going to be 55,599. I'm going to put a line here because this is going to be the end of my positive areas. So far, by combining these, what I did is create this shape. Solid shape. Now I have started making the holes which are subtracting these 3 parts. The first one is going to be this semicircle here, semicircular area. The radius for that small area is 10. So for that small area, pi r squared divided by 2 is going to be my area. And pi r squared divided by 2 is pi times 10 squared divided by 2. Pi times 10 squared divided by 2 is 50 pi, which is 157.08. Now the location of the centroid at x is exactly there because it's at the center, right? So this is going to be 20. But in y, if I'm talking about this, it's going to be 80 plus this distance now is going to be 4r divided by 3 pi. But r in this case is 10. So it's going to be 80 plus 4 times 10 divided by 3 pi. And that is 84.25. Now you do the multiplications. This times this is 3,141.6, and this times this is 13,233.07. And guys, if I was you, I would start putting these in different colors, putting some lines just to be sure that I remember that this is going to be subtracted because this is negative areas. Now the next one is going to be now the bottom part, this, which is basically the same shape with the same area, with the same X location, but the thing that changes is the Y location. Because if you look at this shape now, the 4r divided by 3 pi is the same, but the distance from my axis, remember my axes are here now, this part is this, 50. So for this one in particular, it's going to be 50 minus 4 times r divided by 3 pi. And this is 45.75. Do the multiplication, 3141.6, because it's exactly the same. And in this case it changes, of course, it's 7,187.33. Same treatment, negative, negative, negative. Beware of that. Last but not least, the rectangular portion of the center. Rectangular portion of the center is also a negative area here. This is 20 and this is 30. So 20 times 30 is 600. Location of the center, 20. In Y, well, in Y is going to be 50 plus half of this height. 50 plus 15. So 65. Multiply 12,000. Multiply 39,000. Remember. Summation, summation, summation. And by summation, once again, I say plus, 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 minus, minus, minus. 4,414.16. Summation, 155,783.17. And summation, 146,678.6. And basically, when we reach this problem, everything is done. Because the only thing that I have to do now is, if I want my X bar, get this value and divide by this value, 155,783.17 divided by the summation of the areas, 4,414.16, and that gives X bar of 35.3 millimeters. Units, box, and Y bar is going to be this one, divided by this one. Y bar equal 33.2 millimeters. Units and boxed. And I did this example on purpose, as I do the other one also, but for showing you that this is a way of working it, but it's not the smart solution. So if you use now the smart solution, it's going to save you some time and some really needed time, I might add. If you are in an exam, that time is going to be really, really important for you. So what I mean by a smart solution is this. If you look at this shape, once you got up to this point, come on guys, you are engineers. In less than you know, you are already out of this university and you graduated as an engineer. So you should have some training so far on what to do. If you look at this shape now, let's draw that shape here. This is 30, this is 20, so this is 30. This part here is 10. This part here is 10 also from there, right? Because this is 30, this is 10. And from here, if you want to, this is 20 and up to the base, and 30 up to the other base. So 20 meaning this is also 10, and this is 30. But this is the shape that I want to refer to. This is a symmetric shape. Everything is symmetrical here. So you don't have to be, you know, a rocket scientist, or even, you don't have to be even a civil engineer to realize that the centroid of that symmetric shape is going to be there. So instead of me doing 3 figures, I'm going to do only 1 figure, which is going to be this. So up to this point, everything will be the same. But once you come here, in this part, the only thing that you will do is subtract now this shape completely, which the area is going to be this plus this plus this. What is this plus this plus this? Well, what is this area? This area here is going to be the area of that part. Is going to be, well, I know this is 10, right? Because the problem says that it's 10 here. Look, 10. So it's pi times 10 squared divided by 2. That's one of them. Multiplied by 2 because I have 2 of them. Plus 30, and this is 10. If this is 10, and this is 10, this is 20. 30 times 20, or 20 times 30. And that is going to be 914.16. So 914.16. What is going to be the location of the centroid in X? This distance. What is that distance from here to here? Well, it's given 20 from here to here. 20, because this is 20. So the distance in X is going to be 20, which if you realize all of them are 20, so of course the composition has to be 20. And the distance in Y is also given. I don't have to calculate anything. It's going to be 30 plus 20 plus 15. So it's going to be 65. Multiply this times this, and that will be 18 to 83.2. Multiply this times this, and that will be 59,420.4. Remember, 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 remember. Calculate summation, summation, summation. 4,414.16. 155,783.17. And 146,678.6. X bar, this divided by this, which is the same that we did before. You can copy it again, but it's here. 155,783.17 divided by this, and this one is 146 divided by this, which is 33.2. And you reduce your timing by doing that, just by being a little bit smart, because that's not being even intelligent, that's being smart, just taking advantage of the problem and trying to reduce your steps for solving the problem. Less steps is less time, and it's also less calculations. There are less calculations involved, which at the end is less reasons to mess up a problem. See you during the next problem. Have a good day.